Hello everyone, welcome back to our Theory of Vibration and Aeroelasticity lecture series from the Department of Aerospace Engineering. Today in this section we will explore an important topic called support excitation. Unlike ordinary force vibration where an external force acts directly on the system, support excitation occurs when the basis or the support itself moves and transfer vibration to the structure. This concept is extremely important in the aerospace engineering, especially in aircraft engines, helicopter rotors, spacecraft launch systems, and vibration isolation mechanism. Let's begin our journey into the understanding how support motion influences dynamic behavior. So by the end of this lesson, you should be able to understand the fundamental concept of support excitation and base motions. We will learn how vibrations are transmitted through mechanical systems and how engineers quantify this transmission using transmissibility ratio. We will also apply design thinking principle to solve vibration related challenges systematically. Finally, you will perform transmissibility calculations that are crucial in designing vibration isolation systems used in aerospace and automotive industry. This model is designed for third year aerospace engineering students as a part of their theory of vibration course. The learning process combines theoretical understanding with practical simulations and laboratory demonstration. Students are expected to engage with numerical tools like MATLAB and simulation while connecting these concepts or real aerospace application. The goal is not merely to solve equation but develop an engineering goals and this concept real aerospace application. This goal is not only for the solved equation but develop engineering institution about how structure responds to moving supports and environmental disturbance. Before studying support excitation, students should already understand free and force vibration, spring mass damping systems, and frequency domain analysis. Our learning environment includes multimedia classrooms, interactive demonstrations of different understanding of MATLAB simulations. This combine enables students to visualize dynamic response and content connects the mathematical model with the real-world engineering systems. So here the basics of the main content can be deliverable, can be explained. Let's play the recap of them to summary. Now the engagement techniques are interactive demonstration, grouping of problems and real-world cases. Pedagogy can be used to demonstrate the vibration systems in aircraft engines and aircraft structures. Unlimited objectives and to prepare the students to challenges in innovation controls, vibration controls, and the structural damping. Where the assessment models can be used in the course will be understanding the participation and the learning things from the solving problems. And let us focus on the heart rate. Today topic is the basic excited model. Consider as a spring mass damping system where the support movements with a displacement of yt. The mass experience a relative displacement of x time t, and the difference between these motion determine the dynamic response. This concept is fundamental in understanding earthquake resistance building, aircraft engine mounts, and vibration isolated systems. Frequency response analysis helps engineers predict how much vibration will be transmitted at different operating frequency. Here we can see the figure that has the excited of the force Ft and the spring K, spring concept, and the damper C is used. Where this graph indicates the damping magnification factor was the frequency ratio omega by omega n. This can be used various values and various curves for various damping ratio from 0.1, 0.2, 0.3, 0.5 up to 2.5. Whereas 0.1, I mean 1.0, we will get the critical damping ratio factor. Coming to the mind mapping of this entire topic can be shown here. The support excitation include base, rotation, and seismic excitation. Analysis involves studying frequency response, transmissibility ratio, resonance, and phase relationship. Application extended to aeroelastic flutter, structural control systems, and engine mounting mechanism. Design consideration includes vibration isolator, damping technology, and material selection for the vibration reduction. In case study range for the aircraft wing flutter to the helicopter vibration and the rocket launching systems or dynamic systems. Together, this idea from a comprehensive understanding of support includes vibration in the various structural systems. Let us consider the of the elastic phenomena of combining aerodynamic force, elastic force, and inertia force. We learned the support exercise occurs when the foundation or base itself moves, transfers vibration to the system. We explore transmissibility ratio, vibration isolation principles, and the frequency response analysis. Using this design thinking framework, we systematically approach the vibration problem from understanding user need to test practical solutions. These concepts are directly applicable to aerospace engineering challenges such as aeroelastic flutter suspensions, structural control, and launch vehicle dynamics. In our next section, we will build up the foundation and investigate our more advanced vibration phenomena. Thank you for watching. If you found this lesson useful, don't forget to like, share, and subscribe for more aerospace engineering content. See you in the next lecture. Thank you.